Alright, if the first derivative tells us where a function has critical points, the second derivative test tells us what those points actually are. A maximum, a minimum, or neither. So, by the end of this video, you'll be able to say, okay, that function has a maximum, that function has a minimum, or oh shit, this function doesn't tell me anything at all. So, here are the steps you need to know. First, find the critical points. This is where you set the first derivative equal to 0. And we talked about this in the first derivative test video, which I suggest you watch before this one. Then, you take the second derivative, which we'll talk about later. And finally, you plug the critical point, so the critical point that you got in step 1, you plug it in to the second derivative. Now, here's an important concept you guys need to know. So if the second derivative, which I'll make by f double prime of x, is positive, then the function is going to be concave up. So this is what a concave up graph looks like, right? It's going up. Now, this means that there's a local minimum. This has a local minimum. All right? Now, if the second derivative is negative, it's concave down, right? So this parabola is going down. It's downward. So it has a local maximum. Now, you might be wondering, okay, we have bigger than 0, less than 0. What if it's equal to 0? Well, if the second derivative is equal to 0, the test fails. All right? So, let me write it in red right here, kind of like a warning. If the second derivative equals to 0, test fails. All right? That means you can take no conclusion and you would have to use another method like the first derivative test or like graphical analysis. So that's it. Nothing, you don't need to guess anything, it's just logic. So let's start off with an easy example. Find the local extrema of f of x equals x squared. Now, extrema just means like the extreme points of a function. So the minimum or the maximum. So remember, first step, we find the critical points, and we find the critical points by setting the derivative of the function equal to 0. So let's first find the derivative. So f prime of x is just 2x using power rule. Now, we set 2x equal to 0. If 2x equals 0, then x equals 0, and boom, this is our critical point. Critical point. And it's really important that you guys know these quote-unquote vocab words, because on FRQs like this, you're going to need to justify some of your answers using these, vocab. But anyway, x equals 0, that's a critical point. Step 2, we find the second derivative. The second derivative is just the derivative of the first derivative. Alright, so the second derivative, so f double prime of x is just 2. Now, we plug in our critical point into the second derivative. Well, we can't, so it's just f double prime of x is just 2. And 2 is bigger than 0. And remember what we said. If f double prime is bigger than 0, then it's concave up. So at x equals 0 on this graph, the function is concave up. And we can tell because this is a function of a parabola, but let's not get too ahead of ourselves. So we know the graph is concave up. So x equals 0. So x equals 0 is a local minimum. And boom, that's our answer, right? Since 2 is bigger than 0, we know the graph is concave up, and we know concave up graphs have the local minimum. And you might be kind of confused, what the hell do I mean by local minimum? Local just means around that point on the function. It does not mean the lowest point on the function. That's the absolute minimum. It's just local. So relative to the points around it, x equals 0 is a local minimum. It's not necessarily the lowest the function goes. In this case it is, but it's not always the case. So that's just what local minimum means. So x equals 0 is a local minimum. So now let's go on to our level 2 example. Find the local extrema of f of x equals x cubed minus 3x squared plus 2. Again, we're just doing the same steps. We find the first derivative and set it equal to 0. So the first derivative would be 3x squared minus 6x. All right, we set this equal to 0, so 3x squared minus 6x equals 0. So there are a lot of different ways you could do this. For me, I immediately see that we can factor, so we can do x minus 2, right? We factor out 3x equals 0. So we get x equals 0 and x equals 2, and these two are our critical points. Critical points, good. And now what do we do? Well, we take the second derivative. Well, the second derivative is just the derivative of the first derivative. I can't even talk. So 6x minus 6. And now we plug in our critical points into our second derivative. So let's start with x equals 0. So f double prime of 0 equals 6 times 0 minus 6, which is 0 minus 6 equals negative 6. Okay, and then let's do f double prime of 2, would be 6 times 2 minus 6, which equals 12 minus 6 equals 6. So, f double prime of 0, negative 6. Since it's negative, what does that mean? Well, let me just make this a little bit smaller so we can see better. Right? Alright, sorry. So, what does that mean? Since it's negative, that means at x equals 0. Wait, sorry, I'll just write it like this. X equals 0, there is a local maximum. Max. Because it's concave down. So if you're like kind of confused, like how do I know negative is max? You can just draw it. Negative, I guess our brain kind of correlates negative with down. So concave down, you just draw it like that. You see, oh, there's a maximum. Now, on the other hand, at x equals 2, since it's positive, there is a local minimum. A local minimum. Why? Because positive, correlate that with up, concave up, and we see, oh, there is our local minimum. So boom, this is our answer. Alright, so let's move on to our level 3 question. Use the second derivative test on f of x equals x to the fourth. Again, this is a very easy topic on your AP exam. It's the same steps over and over again. So, first step, we take the first derivative and set it equal to 0. The first derivative of this function would be 4x cubed. Obviously, there might give you something harder, like sine x times 3x squared, which you're going to have to use product rule, but we're just learning how to do these first. If you need help on those types of questions, I have a bunch of derivative videos on my channel, so I suggest you check those out. But anyway, so our first derivative is 4x cubed. We set it equal to 0, 4x cubed, 0, so x equals 0. Alright, so now we take the second derivative, which is just the derivative of the first derivative, which is 12x squared. Now, oh, sorry, I didn't even label it. This is our, what? Critical points. Critical points, and we plug our critical points into our second derivative. Well, f double prime of 0 equals 12 times 0 squared, which equals 0. Alright, so now what does that mean? Well, it's not negative, so that means that f double prime, x equals 0 is positive, so it's concave up, which means there's a local minimum. Alright. No, this is wrong. Completely wrong. Why? This is a mistake a lot of people make. And I just kind of wanted to highlight it. The second you see the second derivative is equal to 0, you stop. The test fails. Right? This is one of our rules, our warning. If the second derivative is equal to 0, the test fails. A lot of people keep going, right, and just assume, oh, since it's not negative, it's concave up. No, it's 0, which means the test fails. It doesn't mean that There's no maximum minimum. It just means the second derivative test is kind of useless here. You're going to have to use the first derivative test or graphical analysis. In this case, x equals 0 is a minimum, but the second derivative test cannot prove that, right? So, even though a lot of people like know this rule, they still mess up. So this is why I wrote this warning in red. If the second derivative is 0, the test fails, you stop, you do a different method. So many people on the tests I've graded have gotten so many points off, not because they don't know the material, it's just because they forget this one simple rule. So, f double prime of 0 equals 0, we're done. Test fails. Now, we can end here, right? Because it just says use the second derivative test. It doesn't say find the local extrema. So the test fails, right? We used it. As I said, there is a minimum, but you'd have to use the first derivative or graphical analysis. So, our big takeaways. The second derivative is fast, but not foolproof, as we've seen here. It works only if f of x is not equal to 0, and if it's positive, there's a local minimum. If it's uh, if it's negative, there's a local maximum. So, if this made sense, you're officially past the hardest mental block with extrema. So next video we'll be talking about inflection points and concavity, where the second derivative really goes crazy. So, if you guys enjoyed this video, I'd appreciate if you liked, subscribed, all that jazz. If you have any questions or any videos you'd like me to make next, as always, leave them in the comments below. And I'll see you guys in the next video. Thank you.